Chain rule is basically a method of differentiating things that are composite functions. So suppose you have a composite function which is f of g of x, then the derivative of this whole thing is basically first f derivative and then multiply it by g derivative. So in the df dx notation, then what this says is df dx is just df dg dg dx. So the notation here is not very useful for one-dimensional thing, but if you learn multi-dimensional differentiation, then you know that this way of writing it down is really easier to see because it's like dg cancelled out and only left with df dx. So some of the applications, the first thing is it's obviously used to differentiate stuff. So for example, if it's differentiating a composite function like sine of e of x squared, so it's three different functions composite together. And by chain rule, it's just each one, differentiate each one and multiply them. So the derivative of sine is cosine, so you first write down cosine of the inside function, which is everything here. And then you differentiate g, e to the something, the derivative is still e to the something, so you write that down. And at the end, you differentiate x squared, which is 2x, and you multiply three of them together. So that's one very easy example. And another use for the chain rule is you use it when you do the fundamental theorem of calculus. So if you are integrating something with f from a function to another function and you want to differentiate with respect to the argument of that upper and lower limit, then you need to use chain rule. And the way to do this, the way to get this formula on the right hand side is through this derivation. So suppose you have the antiderivative, which I call it big F here. By definition, an antiderivative is a function whose derivative is the original function. So by definition, this would be, by fundamental theorem of calculus part 2, you would get the big F evaluated at the upper limit minus the big F evaluated at the lower limit, and then you take the derivative. And now you need to use chain rule because you don't know what big F is. So by using chain rule, you know that the derivative of big F is small f, and it's evaluated as still at the inside function. And then remember, you need to multiply the derivative of the inside function by chain rule. So you need these two extra terms if you are differentiating with something that has an upper and lower limit both as a function of x. And so, for example, suppose you are differentiating some arbitrary function f, which you don't need to know what it is, and you are integrating it from x to, say, x squared, then by the chain rule is by the formula that I just had here. So it's this formula. The only thing you need to do is differentiate the upper limit and the lower limit, which the derivative is 2x and 1 here.